Welcome to the second video where we discuss the problem based on the reciprocity theorem. So in this problem we have to verify your reciprocity theorem by finding the value of current I which is flowing through your 2 ohm resistance. So in order to calculate the value of current I which is flowing through your 2 ohm resistance value, you have to calculate the net current that is emitted due to this 220 source 20 volt source, considering all these equivalent resistance value. So in order to find out the equivalent resistance value, we have to first see that here 8 and 2 ohm both are in parallel with respect to each other. So when do we say that both the branches are said to be parallel? That is when your one end of 8 ohm which is connected in parallel with respect to that of 2 ohm, and other end of 2 ohm which is obviously connected in parallel with respect to that of your 8 ohm resistance. So we can say that both 8 ohm as well as 2 ohm resistance are contained in parallel with respect to that of each other. So considering the equivalent resistance value 8 ohm and 2 ohm, we get the equivalent resistance of this parallel as 1.6 ohm resistance, which is in series with your 4 ohm resistance value. 1.6 in parallel with in series with your 4 ohm resistance. So on adding series we get this as 5.6, and this 5.6 ohm resistance which is obtained by the series equivalent of 4 ohm and 1.6 ohm, which is then connected in parallel with respect to that of 4 ohm resistance. And so the equivalent resistance of this parallel combinations gives you the value of 2.33 ohm resistance. And here we can see that this 2.33 ohm resistance is in series with your 4 ohm resistance. Thereby you get your equivalent resistance of this whole branch network as R equivalent as 2.33 plus 4, which is 6.33 ohm. Since we have find out calculated the value of R equivalent, I have to calculate the value of current I. So in order to calculate the current value of current I can just use the simply the Ohm's law, which is given by I is equal to V divided by R equivalent. In this case it is R equivalent. So what is the value of V is nothing but your 20, and R equivalent is 6.33, which will end up with the value of 3.157 ampere. So the total current that is emitted to this 20 volt source is nothing but 3.157 ampere, considering this all these equivalent resistance values. So we get the 3.157. So here we can further move on as, before entering into the problem, before basically calculating the value of current I will just introduce into the topic of current division rule. So what is this current division rule? Basically that helps you to calculate the value of the current I which is flowing through any of the branches. You can use this rule to find out the calculate that is flowing through any of the branch, whether it may be a 4 ohm branch or it may be a 8 ohm branch. So I have to calculate the value of current I. So I should know the value of current that is entering the 4 ohm resistance as well as the current entering this 2 ohm resistance. So the 3.157 ampere current is same up to this point, that is up to this 4 ohm branch. And here at this node the current basically splits into two, that is a part of current enters into your 4 ohm resistance and another part of current that basically enters into 4 ohm, and obviously at this node again it gets splits into two parts, that is a part of it enters into 8 ohm and a part of it enters into 2 ohm. So that part of current that is entering into your 2 ohm resistance is the value of current that is to be calculated. So I just calculate the value of 3.157 is the same current. So you just calculate the value of current. So your current division rule states that in order to calculate the value of current through any of the branches, that is branch, I say it as branch, you should know the value of main current and the resistance of opposite branch, as well as your resistance of opposite branch plus resistance of calculating branch. So it is very important. So in this case I have to calculate the current that is entering through 4 ohm resistance. I write it as I through your 4 ohm resistance as mean current is your 3.157 which is 3.157 multiplied by resistance of opposite branch. Here you can see that resistance of opposite branch is that. So I am calculating the value of current that is entering through this. So the my opposite branch is nothing but your 4 ohm resistance, because you can see here that at this node the current splits into two direction. That is, it enters into 4 ohm and another part of current enters into this branch. So since I'm calculating the value of current that is entering through this branch, so my this 4 ohm resistance obviously becomes the opposite branch resistance. So which is nothing but into 4 divided by resistance of opposite resistance plus 4 plus. So my the current that is entering through calculating branch, which I mean the current that is entering through the branch that is to be calculated, right? So here we cannot directly write 4 ohm as our calculating branch, because this obviously this current then enters into this node, gets splitted into two that is branches. That is, one through a part of it enters to 2 ohm 8 ohm, I mean 8 ohm, and another part of it enters into 2 ohm resistance values. So you cannot directly write the resistance of the calculating branch as 4 ohm. I should find the equivalent, that is 8 and 2 ohm, which are in parallel. Hence the equivalent value is 1.6, which is in series with your 4 ohm resistance. Hence total values come to be 4 plus 1.6, which is 5.6. So here it is 5.6. So on calculating, you get your value as 1.315 ampere. So the current that is entered into this 4 ohm resistance branch is 1.315 amperes. So again, this current, this 1.315 current ampere then gets split at this node, then again gets split into two paths. That is, part of it enters into 8 ohm, another part of it enters into 2 ohm resistance. So since I have to calculate the value of current I that is entering to 2 ohm resistance, I simply take this sign convention as I is equal to, so what is my main current? Here my main current is this, that is calculated one, that is 1.315 ampere, multiplied by resistance of other branch. Since I'm calculating the current through this branch, though obviously my 8 ohm becomes the opposite branch. So my 8 ohm is my opposite branch divided by resistance of other opposite branch plus my calculating branch. I'm calculating the value of current through this branch, right? So this becomes my 2 ohm as. So the whole answer gives you the value of 1.05 amperes. So this is case one part. In order to solve this, we have to, in this question, basically the problem statement is we have to verify the reciprocity theorem by finding the value of current I. We have find out the value of current I by placing the 20 volt source as it is, which is provided in the question. So in second case, so yes, in the second case, here it is, that is, I have replaced the question, which is nothing but we were asked to find out the value of current I that is entering through 2 ohm resistance. So as per the reciprocity theorem, we have to replace the voltage source as well as the calculating parameter with its equivalent. So if I replace it, but obviously the condition is that we have to keep the, while replacing the both the that is parameters, we have to keep the one point clear, that is we should not opposite or change the sign or direction of the current or change the sign of this voltage source. So I have to keep it as it is. So in the case 2, we can see that the current that was entering downwards is kept as it is, and the voltage source polarity, which was plus minus, is also kept as it is in the figure as shown in case 2. So again, apply the same procedure as that of case 1. You find out the equivalent resistance R. How it is find out? Basically, your 4 ohm resistance, one leg of 4 ohm, another leg of 4 ohm, which are in parallel with respect to each other. 4 ohm and 4 ohm obviously in parallel, so it becomes 4 ohm and 4 ohm parallel equivalent becomes 2 ohm. 2 ohm, which is again its equivalent, is obviously replaced by 4 ohm 4 ohm parallel, and this 2 ohm and 4 ohm which are in series, so it becomes 6 ohm resistance. So 6 ohm, which is in parallel with respect to that of your 8 ohm resistance. So and its parallel equivalent is given by the value of 3.428 ohms. So this 2 ohm and 3.428 are in series, so you get R equivalent as 2 plus 3.428, and so you get the value as 5.428 ampere. So obviously by your voltage, by your Ohm's law, we know that V is equal to I into R, but in this case R is replaced by its R equivalent. So 20 divided by 5.428, you get the value of I equal to 3.684 amperes. So the net current that is emitted by this 20 volt source, considering all these resistance parameter, is 3.684. So as current flows from negative to positive, that is from negative potential difference to positive potential difference, that is nothing but your 3.684 ampere, that is current that is flowing through your anti-clockwise direction in the easy way. So again the current 3.684 ampere again gets split into two paths, that is a part of it enters into 4 ohm, another part of it enters into 8 ohm resistance value. So since I have to calculate the value of current I should take the value of current that is entering through 4 ohm resistance. I have to calculate the value of 4 ohm resistance. Similarly, by current division rule as explained in the case 1, so I have to calculate the current that is entering the 4 ohm resistance, is nothing but, so main current is this current 3.684 multiplied by your resistance of other branch. Since I have calculating the value of current that is entering through 4 ohm branch, so my 8 ohm obviously becomes the opposite branch, which is into 8 divided by, always remember that we cannot write this as a 4 ohm resistance, directly 4 ohm resistance, because here again the current that gets at this node, again it gets split into two paths, that is part of it enters into 4 ohm and other part of it enters into 4 ohm. So its equivalent should be considered, that is 4 ohm and 4 ohm which are in parallel, its equivalent is 2 ohm resistance, 2 ohm along with series with respect to 4 ohm resistance, which is obviously 6. So I should be writing as 6, which is nothing but 2.105 ampere. You get the total answer as 2.105 amperes. So next is, so the current that is flowing through a 4 ohm branch is simply 2.105 ampere. Again at this node the current again splits, so I have to calculate the current I that is flowing through 4 ohm resistance. So I simply write the net current I, sign conventions by using I as a sign convention, as, so main current is nothing but 2.105 multiplied by the resistance of other branch is obviously 4 ohm, because since you are calculating the value of current that is flowing through your 4 ohm resistance, so my 4 ohm resistance become opposite branch divided by 4 ohm plus the calculating branch is 4 ohm, since there is no other branches supported here in this network. So my only the 4 ohm is only left out part, so I write it as simply 4 ohm, which is, you obviously get it as 1.05 ampere. So even by interchanging, the main theme or the main part of the reciprocity theorem is that you have to verify it by interchanging the parameters, that is your 20 volt source, which was obviously replaced, which was earlier in the first question, So and now point we can see here, that is the current I that is flowing through your 2 ohm is obviously same, which was calculated in the first case, is obviously same as the of second case. Hence thereby we can obviously write that reciprocity theorem is verified. Obviously the problem is a bit lengthy, but it's easier if you know the basic concepts. And yes, this was all about the problem. Thank you.